Hello, everybody. As I said, it's really amazing to see you all again. I do hope you enjoyed the session yesterday. Today, we have another amazing workshop lined up. It should really help you with your projects and yeah, really help you familiarize yourself with the Solidity. Um, Before I hand over to Matheus, I'd love to quickly make a couple of announcements. So firstly, I'm sure many of you are going to be thinking about your projects and what you might like to build. If there are any of you who are still looking for team members, once I hand over to Matheus, I'll drop some links in the chat. They will be to the team formation channel where you can reach out to the other hackers and potentially find some teammates for this project. And the second link, which I will drop in the chat, is to my Calendly. If anyone has any questions and would like to book a quick slot in my calendar, it can be anything about Hackathon. Please feel free to do so and book in. It'd be great to speak to you and get to know you all a little bit better. But that's everything from me. I'm really delighted to have Matheus join us today. Matheus teaches on many of our courses and programs, including our Solidity Foundation course, which is actually kicking off on Friday. So for any of you who enjoyed the session today and would really like to consolidate your skills, that's a really great opportunity for you to do so. But as I said, that's everything from me. Matheus, I'd love to hand over to you and to get the workshop started.
Thanks, Sorry. Hello, everyone. GM for you all. If you are really into Web3, you should always GM, like drop GM here in the chat. Let's get this ball rolling. And yes, if you don't have plans for your Friday, let's keep on, like already said, to solidify your Solidity knowledge, no pun intended. So you can pick more on the underlying concepts of block formation, what is a state, what's a transaction, all of that. But for today and tomorrow, we are going to do a very hands-on experience. I'm going to put you in contact with the documentation. I'm going to put you in contact with the actual tooling so you can have a good track, a good direction to follow while learning how to build your D app with Solidity. Okay. Yeah, that's a good observation there. Or if you would like to ask a question, there is a pane for that in the chat here on this application that you can ask any question, vote on questions, and whenever possible, I'm going to pick on those. Okay, Hori is going to be answering the questions about the program itself, about Encode, about all the general inquiries you might have, and I can answer the things about the content here, about the Solidity, why it's not working, how to do everything, where to find the things in the documentation, these kind of questions. Okay. So good. I cannot see your faces in other applications we use. I can see all your beautiful faces, so I can know if you are like question mark face or if you are following a breeze. Usually, I recommend picking a good beverage to stay hydrated. Some good snacks can help as well, so you can have a good ride here today. Okay. So what I'm going to need from you, some attention, like for 50 minutes or so. It's each time harder to keep attention. Or attention is spending that long. I'm competing with so many sources of disturbance, right? So this is why every now and then I try to make a joke. I try to get your attention. I'm not very good at this. Sorry for the bad jokes, but it's for a good cause, for you to stay entertained and pay attention. Other than your attention, I'm going to need a browser that you probably have and internet connection. If you have all of those, we are well served because we are going to use this IDE here. Let me start sharing my screen. So let's begin. If we don't have any questions, I guess I can move this tab for another place. Now it's working better. I can see the questions and the content. Good. So I invite you all to open this tool called Remix. You can find the link for it here in the documentation. It is good to go for the documentation to copy the link. Why? Because this is going to interact with your wallet. Okay, so there are a lot of scammers out there. So when you open Remix, you'll can see that you have like a scam alert here. If you are not inside this website, it could be in a fake remix, something like this, that could rob your money. So be careful, okay? To interact with the network, we are going to use a wallet connection. For example, here I'm going to use MetaMask as my wallet connection to the Ethereum ecosystem. This is not super needed. We have other environmental options as well, like a virtual machine or such. But if you want to do those steps as well of doing things on a public blockchain, not in mainnet, on testnet, I do recommend you now to install another wallet or pick another browser or something, because please don't use your production keys here, production wallet. You could lose money. The risk is too high. If you want to lose money, there are plenty of ways to do that in Web3. Do not do this in my bootcamp, in my lessons, if possible. Okay? So you should have, when you open Remix, you should have, no questions yet, you should have this file explorer pane here in the left. And if you click those three bars here, those three horizontal bars, you can create a new workspace. It's a new folder, like a new space in your browser for you to have new files. And this is going to prompt you in a model for filling up some options. The template, first option, we are going to leave on basic, and we can give it a name. For example, Encode Solidity Workshop. Or give it any cool name you may find. Okay. So here we are going to create this basic workspace that is going to come packed with three folders: contract, scripts, test. Because for today we're going to go very lightly on what is this storage Sol doing and what is this smart contract here. Okay, let me turn this off so it doesn't confuse you. Let me do that again, just 1 second. So we are going to create a new workspace from the basic template, Solidity Workshop. Gonna be like Encode Solidity Code Solidity Workshop. Now it's okay, we have this storage.sol. Okay. This is a smart contract file, Solidity file, that when compiled can become bytecode for us to do interactions with it. What does it mean? So before we jump into the language, I would use like 10 or 15 minutes of your time to understand what exactly is this bytecode doing in the blockchain. It is quite similar to other blockchain networks, okay? But for the EVM, Ethereum Virtual Machine, we have to comply to some certain structures, and we have some certain limitations, okay? So it's going to be worthy of your time.
Matheus, are you
Yes.
able to zoom in ever so slightly just to make it a bit clearer?
Let me try. Okay. Let me try to zoom in everything. Okay. Better now.
Thank you.
But that's the things that are on my screen right now. The little text are not so important. Right now we have a workspace with the blank template. We are going to pick from here. Okay. Before we reach on the smart contract part, let's remember a basic starting point for understanding the how this can be a program, how this can work, how this can do changes in the state of the blockchain in that extent. Because if we do a transaction, a normal transaction in blockchain, let me say I'm going to send someone money, this transaction is going to have some structure, okay, and it's going to be handled by the blockchain. There's a block production method, blah, 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 not so important for today. And to demonstrate that, I would invite someone to paste your address, your Ethereum address here in the chat, so I can send you a great amount of fake money, of course. Let's see who's quick on that. Isla, K, you had that. You were expecting for this. That's not possible. You went too fast. So, okay. Not to give you tax problems, okay, for you not to have any troubles with your tax filing, I'm going to limit the amount of money I'm going to send you for 0.001 Sepolia ETH. Okay, it's an asset inside the Sepolia network. Unfortunately, I cannot enlarge my MetaMask, but this is me typing an amount of 0.001 Sepolia ETH. Okay, it's not worth anything, okay, people. It's fake money that you can get from free from faucets, just for us to understand what's the transaction. Okay. Now let's use an application called EtherScan, a block explorer, to get more context on it. Now let me zoom that in. It is a transaction sent from my address. This is my address. Let me copy it for you here in the chat so you can be sure. My address. This was sent from my address to Isla's address, and it has some properties of value, of fees. Yes, I almost paid as many fees as the value I'm sending. And this caused a state change in the blockchain when it was confirmed in a block. This is similar to Bitcoin. This is similar to a lot of other blockchains. When I send a transaction, when it's accepted by the network and included in a block, it possibly causes a state change. We can see this state change here in the pane of state, and we see that we have 3 state chains. One that is my address, that is losing some assets, losing some balance. I lost 0.01 plus some more amount that I paid for gas. I received 0.01, so the balance increased. Oh, come on, you have more ETH than I do. Why I'm sending you money? Should be the opposite. These are sometimes hard to get in the faucets, but we're good. No hard feelings. And the miner receives some money. So this, you can see that this is not exactly equal to that. That is a mechanics here of burning and minting Ether, but that's not important for today. This means that this transaction, when included in the blockchain, causes a state change for changing the balances of the accounts. Okay, so I sent this value here. So far, any questions? Okay. Would it make sense to send a transaction of 0 value? Say pick an address here. It's possible, okay? I can. If I try to send here 0 value, it is possible. I can approve this. Sending 0 value is going to spend gas, but it's possible. Would it make sense? I know I can't see you, but like type here in the chat on your hypothesis. Let's say I go for my bank manager and say, hey, I want a special transaction today. I want to send $0 for Hori. This is like, what? Yeah, like I can send a check with a message of $0, something like this. Could have some uses, but monetary wise, transacting assets, unless some of you see a reason for that, I wouldn't see a reason for sending for this network transactions of 0 value. That is correct. Sorry if I misspelled your name, Matan. Oh, Matan. If I send a 0 ETH transaction, I would still pay gas, and this would make me lose money, actually. I start with a balance, I send 0 money, have a lower balance, because I paid for gas. That is true. To record a certain account information, yes, could happen. Sign a message, record a message, something like this, or cancel another transaction. There are some situations like this, okay? But If we look on this application, EtherScan, all the latest transactions, the list of latest transactions, we are going to see that the majority of the transactions in the recent history are sending 0 ETH. Is this because they are spamming the network? They are signing messages, or they are wasting money, creating scarcity of Ether? What they are doing? Those transactions here, people, let's pick any random transaction, like propose block on some zero knowledge or something. Those transactions, they are not sending money. They are being called from a person to another person. There is a detail here that this person is a smart contract account. It's not like Isla's address that is like an externally owned account. Someone, a person or a machine has that key. Here is a smart contract account. And the difference, the key difference is that inside this smart contract account, we can see that we have a contract. We have byte code on it. I went to the contract address, tab contract, and I can see all of this. Those are hexadecimal characters. Each 2 hexadecimal characters forms a byte, and all of those bytes are doing some opcode, some operations, some algorithms, some procedures that this contract can run. The thing is, when I call a transaction in a smart contract, I can pass value, I can pay value for that smart contract or not. That's not important. But what I need to do is to pass data. So into the input data of that transaction, I'm passing a bunch of bytes. That when those bytes are evaluated against the bytes of the smart contract, input bytes, smart contract bytes, when those 2 are evaluated inside the EVM, it can produce state changes, like someone changing balances, like we just saw, and some things more complex, like this can look complex, but imagine this like it's a database where I have some number that is increasing. Okay. I sent some bytes in the transaction without money, sent some bytes, executed those bytes against a code that was stored inside a smart contract account, inside the EVM, and this produced a state change. This is a smart contract. It's more than just sending assets, sending money all over. It's actually something that you can program, something that you can create checks, if and else, intelligence, algorithms. You can actually make this process intelligence through some checks, summing, subtracting, dividing, multiplying, all of that. This is a smart contract. This is what we write. Now we go back for remix. This is what we write when we do this kind of script, a smart contract script. It's not something that's going to be executed line by line. So we have an object-oriented structure here that when compiled and deployed, we are going to have some bytecodes in the blockchain like this, that we can send transactions to it, and we can potentially produce state changes inside that smart contract storage when we do those transactions according to the code that we put. Okay. Questions so far? My question tab is empty. See a lot of chat, but most no questions. So this is a smart contract. And to build this smart contract, instead of doing the bytes one by one, like a machine, who writes code like 010001, like If you do that, I'm quite sure you're not going to pass those captchas around there. Are you a human? Perhaps you are, but there are better ways to spend your time. You can, instead of writing this byte by byte, hexadecimal, you can instead use a programming language like Solidity, like Yule, like Viper, many others that can be compiled to bytecode. So when you store a smart contract in the blockchain, you don't store the code of it. Don't store the lines of code. You can verify and publish, of course, but that's not storing the lines of code in the blockchain. It's stored in EtherScan. In the blockchain, you just have the bytecode. So this is the Solidity smart contract that can produce those bytecodes. Okay. Okay, feel free to interrupt me if you have questions. Let's keep rolling. Okay, does it mean that only smart contracts can interact with the blockchain? For example, change data stored in the blockchain. We can change a very simple kind of data without a smart contract, like we did when I sent a transaction here. So we are altering data, balances of people, and nouns. These are the two things we can do without smart contract. Change balances and change the nouns of accounts. Like my account had submitted 52 transactions to the blockchain before. Now it has 52, has sent 53. This is one of the things I can update. And the balance of those accounts I can update. Anything else in those account storage need to be updated with smart contracts. Okay. Thanks for your question. Yeah, there is a question pane here to organize the flow of the lesson. Like I have a question here. Why it's stored in bytecode on the blockchain? For the blockchain to operate, everything are bytes. Okay. There is no such concept as like strings or blah 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 store in the blockchain. Everything is bytes for performance, for speed, for optimization, upgradability, all of that, and those bytes are agreed upon in the EVM versions. Okay? To fully explain that, that's quite deep on the opcode itself, but each of those little bytes can, when grouped, can refer to specific opcodes inside the EVM. So how to properly assemble those opcodes like Lego? We can write a Solidity smart contract. For doing this, we need to fulfill the Solidity Grammar. This is a very important part of the syntax for writing the smart contract, because we don't have yet a language where you can do this large language model or something that you can do like write a smart contract that stores a value to be retrieved, fetched later on. And this could be possible in the near future. We are getting closer to this, but before that, we still need to comply to syntaxes. So for example, one of the things we need to comply for the grammar is the structure that it is, the layout of a storage, the layout of a Solidity source file. We need to begin with an SPDX license identifier to cover the license of that smart contract. So this is why we have this first one. Actually, it's optional, but not that much. Can give a read on that later on. Second thing, version pragma. We need to comply to the version pragma statement. If we don't put it, the smart contract can't be compiled. Okay, so we need to put like this. This is specifying what version can be used or cannot be used for compiling that text file, Solidity file, into bytecode. I can limit that because there are indeed a lot of breaking versions. So if I miss one character, like pragma solidity within capital S, it already breaks. So this is syntax. If you are a coder or dev, you might be familiar with that. This is complying to the syntax, to the grammar of the programming language, because each character, each space is important. Okay?
Matthias, we've had a question in the panel which says a decreasing value of state difference means what? Does it mean a transaction is invalid?
Let me see. Is that in the questions or in the chat? Let's see.
I've copied all of the questions over to the question panel, so if you just want to load
Perfect.
that one up, they're all there for you.
A decreasing value of state difference means what? The transaction is not valid or something? No, actually, for example, here, when I have sent to Isla's address some value, I decrease it from having before 4.456, not intended, but having after 4.455 and a little less. So I've lost some assets. I have a decreasing balance because someone else is increasing. It's like almost a zero sum. If it wasn't for that, it would be a zero sum transaction. It's, if you are curious on that, it's not zero sum because of the mechanics of the ERC 1559. Here in the ERC 1559, they introduced this mechanics of burning and minting ether. This is why it's not a zero sum entirely, but it's close to it. If I send some value, I'm going to lose, someone else is going to win. So this is why we have a decreasing value of state difference, okay? And another question, the gas fees from empty transaction for the smart contract is like an execution cost. Yeah, it costs from the, we are going to see more about that in the foundations. The cost of gas that we pay, it is a multiple of the gas price and the gas used by this transaction. Okay, the gas used is fixed. The price you can pay more or less. Okay, so the more execution you do, the more gas units you use, and the more you pay, even if it's a zero value transaction. Okay.
I think the question asks who would pay that gas fee.
Perfect. Whenever we send a transaction for a smart contract, even if it is a smart contract, we pay. The person that initialized the transaction pay for it. Okay. We're not speaking about account abstraction, about paymasters, blah blah blah. It is the normal transaction we send for a blockchain. The initializer of the transaction should forward enough money for paying the gas along the course. Okay. Good. The person that deployed the smart contract doesn't pay for anything else unless that person calls later on. Okay. Okay. It's like whatever we code in the blockchain, it's finally a transaction and we'll make some state change. Yeah, but the thing is, when we call a smart contract, we don't need to code the call. We can just call a parameter on it. We're going to see that in this example. Okay. In this storage smart contract, we have a function to store and a function to retrieve. Those are marked public. We're going to see that. Since they are public, they have possibility to be called from all the smart contracts and from outside of the blockchain to produce output or even state changes. Okay, so I don't need to write the code and send, write the code and send, write the code and send. No, the contracts are there. I just pick a function and call it passing the parameters. Okay. So let's roll back on this. We saw that we have the layout of the file, should have a license identifier, and we should have a version pragma. Okay, those two are required for me to start coding. In this first contract here called storage.sol, I already have those placed. We can also have comments blocks like this one. This comment block is giving a title for that smart contract. It is explaining some things about this smart contract, and is placing a custom dev annotation of a script that can be run for it. That's not important for us, okay? We can even remove those comments if you would like. Then we have this structure for creating a contract storage. This is similar to an object. If you are familiar with other programming languages that are object-oriented, this is similar to an object because it is not going to execute line by line. It's not like this line 7 get executed and then this line 13 get executed when you deploy that smart contract. No, it's not going to execute it line by line. It is going to define this object-like thing in the blockchain so that I can call and refer to those things by passing the name. The name of the variable in line 7 is number. So when I call the number, I can get this variable. When I call store, I can have this function. Okay, this is why we say that this contract that we create is somewhat similar to an object in other languages. Okay. Yeah, I see some questions here in the chat in the meantime. Yeah, if you miss anything, let me know. I can repeat every of those steps. So if we go for that grammar, let me see if I post the link. I didn't. This is the grammar. This is basically everything you need to understand for being able to write a smart contract in Solidity. For example, we are inside a contract definition. Let me teach you how to read this grammar. A contract definition that has like a flow chart. It begins here. So we can use the word abstract or not in that flow chart. So we could start with the word abstract or not. In this situation, I want to use it as a normal contract. I don't want it to be marked as abstract. Not going to cover abstract contracts today, but imagine this is an option, okay? So there is a path up here that I can skip. Now I need to be contract, exactly contract. No capital C, no spellings are accepted. It needs to be exactly that. And then we can pick an identifier. An identifier can be any word. Any word can come up with a contract, banana, contract, anything with capital letter or not. We usually put the capital name in the contract just for it to comply to the naming conventions, the style guide of Solidity, okay, but it's not needed. The only thing that we cannot pick for an identifier, for function names, for variable names, for contract names, and so forward, are reserved words like contract pragma. That's not possible. Contract solidity. That's not possible. Contract, that's not possible. Get the idea? This is the identifier. So if you follow the grammar here, we have an option of doing some inheritances, make a contract inherit to the other. We're not going to do this. We follow the down path here. So I open and close curly brackets, and then I can put contract body elements. Okay, so this is reading the grammar. You can get a clear reference of how to code each and every feature of Solidity language by following here this grammar. Okay, usually you learn it first in the implementation, and then you read the grammar for remembering, but it's good to have that in hand. So here we have something called state variable, and here we have something called function method that can be called. This state variable is something that is persistent in the contract, that if I call this again in another transaction and again in another, I'm going to have the same value in all of those. Or if the first one is changing that value, the second one is going to see that value. Okay, This is something called storage. It is persistent. If we do this inside a function, then we use another thing called memory. If we have a variable inside a function, it is going to be ephemeral. The next time you run that function, it is going to start cleared. So even if I waste like 1 megabyte of data in a variable for computing a model or a parameter or something like this, and then I use that inside that function, if I run that function again, I cannot use the memory of the previous execution. That's not possible. This is only possible inside a smart contract if we declare a state variable. Okay, EVM is prepared for that. So you can see for a function have lots of words. For example, in line 21, function retrieve, it's public, it's a view, it returns a number. A lot of things just for a function definition. Yeah, but this is how we have function definitions in the grammar. Look, in the grammar of Solidity, every function definition should have function, identifier, there are some other options here, parameter list, that I can pass for that function or not, should define visibility, state mutability, sometimes modify vocation, if it's virtual or not, what it overrides or not, what it returns, and the parameter list. So yes, function definition can be quite big, sometimes bigger than the function implementation itself, like here. This is important for the EVM. This is why Solidity is like it is. Alessandro, this is a good question. There are some AIs too that can accurately create smart contracts yet, a lot, and they generate Solidity files mostly. Okay, you could have an AI that generates bytecode directly. I didn't see any of those yet, but I know some very good tools that can use ChatGPT or other models with LLMs, large language models, to generate Solidity code for you with quite a good precision. Okay, a little more precision, 100% less rug pulls. That's a sweet spot for writing smart contracts. Okay, so let's play with it. Let's see how this smart contract behaves when we deploy it to the blockchain. You can see this file storage.sol inside the contracts folder in your file explorer. You should select it if you haven't yet, because now I want to compile this with Remix in this tab, Solidity Compiler. I can turn on auto compile, is this first checkbox here in the left. It's very useful. Or I can hit compile directly. I usually keep that marked all the time, because now every time I change anything inside the code, it is going to compile a new bytecode for me. What is this bytecode after all? I can click and copy here, paste, add, paste it here. This is the bytecode for that smart contract. It has all the needed code to execute all the functionalities we have coded here. The functionality of this state variable with persistence, the functionality of that store function that receives a parameter and is stored in the blockchain, and the functionality of a retrieve function that, when called, is going to fetch the number stored there and return for whomever is calling. Okay, this is what the bytecode is doing. So after I have the bytecode, I don't even need the code itself anymore. I can interact with everything even without the code. Okay, let me see those questions. A lot of chat here, but okay. Now that I have it compiled, I can go for the last step before getting that contract to a blockchain. That is deploy and run transactions. This last tab. This means that after I have compiled my smart contract, I can pick an environment that is by default connected with a virtual machine environment, a blockchain, a lightweight blockchain running in your browser, and interact with that compiled bytecode, for example, deploying it or calling functions on it. Let's start with this environment. Let's start with the virtual machine blockchain that we have by default. It's a virtual machine in the version of Shanghai. It's not so important, but the good part of it, the perk of using a virtual machine, is that we have an array of accounts, pre-funded accounts that we can use. Can we withdraw 100 ETH? Who doesn't want 100 ETH? Could buy some things with 100 ETH. Well, we can, but this network only exists in my browser. So it's very difficult to convince anyone to accept this as a payment. I would need to plug that into my browser every time. So this is fake money, fake Ether that only exists, only resides inside my browser. Okay. I can choose those accounts here. The default is to pick the first one. I can set up some other parameters that are not important for today. And we are going to use the storage contract here that we have just compiled to deploy it. I just need to click that orange button. And since this is a virtual machine blockchain running in my browser, this is going to be real quick. In a second, I have deployed this smart contract with this transaction here. I can see here down in the chat. I can even expand this. So that address 5B38, 5B3 here, deploy that contract address with some code by sending this input here to the blockchain. Let me send this input here in the chat for you. Too many letters. Can't send. Notepad. Okay. What this looks like, what this input looks like, bytecode. This is exactly the bytecode of the contract that we are passing as input of that transaction. When that hits the EVM can understand that this is a contract creation transaction. And then we have that stored in that place in that blockchain. This address D91 blah 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 is the address of the deployed smart contract inside this virtual machine blockchain that now I can interact. I can retrieve the value of number by clicking here on retrieve. And also I can pass a number to it, for example, 42, to store this number there. I'm going to pay gas when I do this, when I store this number in the blockchain. And if I try to retrieve later on, I can get this value. So it is a program, it's working. It's not super useful of a program. It's a very educational program, something like this, not going to be piece of the smart contracts that you develop later on, like a token would be or something. But it's good for understanding those simple mechanics. Okay. Sarah, this is a good question. The smart contracts only deploy when there is a transaction involving 0 ETH. So you can, two things, you can deploy a smart contract just like we did now, and we can call a smart contract function like this retrieve, like this is store 49. This is calling. It's going to be a little more explicit when we connect MetaMask here, okay? It is possible to send money for a function. There are two things we are paying. We are paying for the transaction and for the function when we send money for a function, okay? This is possible if we look here in the grammar. If we mark those functions in an option of payable, oops, not here, payable. Let me find here. Okay. These are the state mutability options. We sent for you here in the chat. So this would make it possible to pay for a function. All that from paying from, I pay for the transaction, and on top of that, I pay for a function. Okay, that's possible even when deploying a smart contract. That's not what we are speaking here. We're speaking about just calling those functions. For example, for retrieving and storing values here. A dynamic static staking contract. Get that? That's not covered today. Sorry about that. I could pick on that question later on in the Discord. I don't know if I'm speaking about the function calls itself. If you would like to elaborate. So this is neat because we can do all of those calls quickly. We can use all of those pre-funded accounts. But what if we want to actually use a public blockchain? I want to see those transactions happening in the EtherScan, in a blockchain explorer. How to? There is an option for that in Remix. You can pick an option for environment of injected provider, and this should prompt for your wallet, for example here, MetaMask. In my situation, I have this connected already, but for you, it should prompt like a confirmation for you to choose what account you want to connect with it, and if you want to connect or not in the first place. Okay, just one sec. If you do that now, you should connect your MetaMask, your wallet here, to see your account listed with your balance. This should, like in the virtual machine, we had an array of accounts pre-funded. Here, it should only list the accounts that you connect on it with your wallet, so that you can choose which account you want to use, and you can see the balance in that network. For me here, for example, I'm using the network of, let me see, network of Sepolia. Okay, so that I can get free Ether there easily in a faucet, and I can test those smart contract executions. So what I'm going to do is that now that I have connected to that injected provider, I'm going to ask for a deploy transaction. But instead of directly processing this transaction inside my browser, now MetaMask is asking me if I want to confirm or reject that transaction. Okay. If I reject, that's not going to reach the network. It's not as simple as the virtual machine environment that it just fire and go. Here, when I deploy with my MetaMask, I need to approve, I need to confirm. And if I confirm, this is going to spend real fake money, not fake money like the virtual machine in my browser. This is a transaction being sent from my account, from my address. I'm paying 0 Ether. You see, Sarah, this is sending 0 Ether for deployment. I could send Ether. There is a possibility for that. There is a technique for that. But here, I'm sending 0 Ether. And I'm passing the whole bytes of that contract code into the input data of that transaction. Okay. It's taking a while to confirm. Just said that and it confirmed. Good. And then now I have this parameter. I have a smart contract created into the blockchain. Close those here. This is the store contract that we have created. Here it is. The storage contract. And whenever I want to call a function on it, look how interesting. If it is a retrieve function, I can call directly for free. I don't pay. I can evaluate the state of the blockchain through an RPC connection with a node or with the provider for free without paying the gas. Why? because if I'm just reading, I'm not going to change anything. I'm not going to change my nouns. I'm not going to change the state, the balances, or nothing. I'm just going to read, evaluate the return of that function. This is why we have this view keyword. This view keyword states that this is not going to change the state of the blockchain. This is different from the store function. If I try and call this store, since it doesn't have the view keyword, it doesn't have any keyword for the state mutability, so it's the default state mutability called non-payable. It's a misleading name, but let that slide for the moment. I don't pay for the function, I pay for the transaction, okay? But it is non-payable. So I click on the store. Now it's going to prompt MetaMask again. It's not going to straight send that for the blockchain because that could cost me some money. So I need to confirm this. And before this transaction is confirmed, the retrieve is still 0. I can keep clicking. Now it's 42. It was quick. I was hoping it would take a while. Now it's 42 because it confirmed. But in the first 2 attempts, I got 0. Even after I click it on the store. Okay. As I can see this transaction here.
Matheus, we might have
I'll
time.
pick
A couple of questions, but yeah, if you'd like to finish off, and then maybe the last.
up now. And if I look here on the transaction we have just sent, we are not sending code. We are just sending one parameter here of method ID. Sorry, those bytes called method ID. That is the function we want to call. I'm not sending the code for that function execution. I'm just sending what function I want to call. And I'm passing the value 2a. 2a is 42 in hexadecimal. You can view the decoded input here. And then we have the data for that number here. So when we call non-payable function that can change state, we don't pass code for it. We just pass a method ID selector and the parameters. This is a smart contract. Okay. The smart contracts are not needed for every use case of the blockchain. For example, we can exchange assets. We can view assets. We can view balances. We can keep track of individual decimals like Wei units or Satoshi units, like the ordinals. All of this is possible without smart contracts. Okay. But yes, everything on top of that, you would need smart contract for developing this, at least in blockchains that are similar to Ethereum. And essentially, smart contract is the logic of a program, and the transaction is what runs that logic and keeps a record of what had happened. Yes, a record inside the block, but there is a shared state record in the whole blockchain at the same time that is updated. We can discuss more about this into the Solidity foundations. Okay, what is this shared state? What is consensus? What is this state machine that is updated when we have transactions and all of that? Okay. I guess this is it. Hori, any other questions or?
Yeah, exactly. As you say, I think that's everything from the chat. So I wondered if perhaps, obviously, you return for part 2 tomorrow. Potentially, you could just give us a quick overview, maybe a little teaser ahead of that session tomorrow.
Perfect. So tomorrow we're going to code. Today I didn't code any line of this. Tomorrow we're going to be actually writing codes with everything from what we learned today. Hoping to get you excited.
Cool. Maybe one more. Obviously, we have lots of university societies and communities. So I know today we've kind of covered all of the technical information, but perhaps just some general tips for people who are looking to break into the Web3 industry. If you had any anything you could share on that?
Of course. First of all, teaming up. Those hackathons are great for that. If you find a team of people thinking of the same thing, working in the same directions, and create a bond that is worth more than anything else. Like things happen in our lives, people. If we have a goal in our heads, but something is happening in my job, in my life, I could easily let go of that goal. When I'm together with people with the same shared goal, we can share experiences. We can have recurring meetings. We can have like a bounty that we want to win together. This really creates a momentum. Okay, so this is a very good first step to enroll in a hackathon, in a boot camp, create a group. This can really give you a momentum for pushing forward.
Perfect. Yeah. And I guess that just highlights what an amazing kind of opportunity this is for those of you who are looking for a team to build with. We just really encourage it. You give it a go, build something, attend these workshops with Matheus. As he says, it's just a great opportunity for you to potentially start your first steps into a career in Web3. But I think that's all we have time for today. So I think I speak for everyone when I say, Matheus, thank you so much. It was a really enjoyable session. Even a couple of dad jokes in there too, which is always good. But yeah, we look forward to seeing you again tomorrow. Thank you to all the participants. Thank you for some great questions. And yeah, let's do it all again tomorrow. So bye-bye. See you soon.